Okay, in this question, what we're going to look at this question. We're going to expand 1 plus k to the 1 plus kx to the n, and we know in ascending powers of x, and we're going to try and match it up with all of this so that we can find k and n. So let's start off by expanding this and getting all the x squared terms out. And so we got 1 plus kx to the n equals, we got n naught, nc naught of 1 to the n times by kx to the 0. Now I'm not going to keep writing 1 to the n minus 1. We know that 1 to the n is 1, and 1 to all powers is 1. nc naught is 1, kx, the naught is 1. So actually we get the first term 1, which is what we hope to get because that's what we're trying to achieve. So plus nc1 of 1 to the n minus 1 is 1 dot kx all to the power of 1. And now we need to get this squared x squared term nc2 of 1 to the n minus 2 dot kx all squared. 1 to the n minus 2 is still going to be 1. Any 1 to the power anything, always 1. Plus, and you've got other terms going on. But we're not interested in them because that's all we're giving in the information in the question, and we're trying to find just k and n. So let's just work out what this bit gives us. nc1, if you remember, is always n. Every time you expand, if you look down Pascal's triangle, you know this gives you the leading leading edge of Pascal's triangle, all ones down the edge, and then the next term is always the same as n. So we're just going to write n here. I could show you how to calculate that as well. Times by kx to the 1, which is just kx. Now the formula, as we know for NCR, is n factorial over n minus r factorial. R in this case is 2. R factorial, 2 factorial. And we're going to times that by kx all squared, so it's k squared x squared plus, and so on. Now, what have we got? Well, so far we've got that, let's just change my highlighter color, this one here, minus 4 is going to be equal to my nk here. Get another highlighter color, something a bit bolder, over pink. The minus 15 over 2 is going to be equal to all of this bit here. But we need to simplify this first. So let's just write out what we found so far. We know that minus 4 here equals nk here. And we know 15 over 2 we equal all of this lot. Well, how can we simplify this? N factorial we know is the same as n times n minus 1 times n minus 2 times all the way down to 2 times 1. Oh, I've forgotten my k squared there, so let's just put that in. We'll put it on the top of the fraction. Imagine this is k squared over 1 times it, so you get n factorial times k squared on the top and just what you got on the bottom. Now n minus 2 factorial is the same as n minus 2 times n minus 3. It's just a little mistake there, let's just correct that. So we've got n minus 3 here, times all the way down to times 2 times 1. And I mustn't forget my 2 factorial, so we've got times 2 times 1. Now what we will notice is this n minus 2 here will cancel out with that n minus 2. And the n minus 3 will cancel out with what the n minus 3 is here, and so on and so on and so on until we get down to 2 and we get down to the 1. So all that we are left with on the top is the n times n minus 1 and the k squared, and on the bottom just 2 times 1, which is 2. So let's just simplify that expression. So we're going to get 15 over 2 equals n times n is n squared times minus 1 gives us minus n times by k squared. I'm going to not multiply this all out for good reason in a minute. And that's all over 2 times 1, which is 2, so we can cancel out these two 2's. It leaves us something a bit simpler. Now, minus 4 equals n over k. Let's see if we can replace this k so we get something just in ends. So we divide both sides by k, we get minus 4 over k equals n. And that's not how I'm going to replace the k. Daft of me. Minus 4 over n equals k. If we divide by the k to get, divide by the n to get just k on its own. So let's substitute that into here. So I'm going to replace cos minus 4 over n equals k. I'm going to replace that k there with minus 4 over n. So I get 15 equals n squared minus n times by minus 4 over n. And I've got to square all of that because k is squared. So multiply that out. I'm going to get 15 equals n squared minus n times by 16 minus 4 squared is 16 over n squared. Let's get rid of this fraction. Now, a lot of people would cancel out here. If you cancel out, you're going to lose some factors, you're going to lose some solutions. So I suggest you don't cancel out here. Let's times throughout by n squared. Get rid of the fraction. 15n squared equals 16. Let's put 6 there. 16 times n squared minus 16n. And then we subtract the 15n from both sides, so we get 0 on this side, and we're left with n squared minus 16n. Factorize that. Take out a common factor of n, so we've got n. N times n gives me n squared. N into 16n gives me minus 16. So that we can see n equals 0 or 16 from this expression. But if you put n equals 0 in this, then we don't get a solution for k. So n can't be equal to 0. Okay, this won't work. We can't work out what k is if n equals 0. And also, if n equals 0, we have a trivial expansion. Okay, the answer is just 1. Yeah, when you expand to the power of n is 0. If this is n to 0, then all of this is going to be just 1. So it doesn't matter whatever k is. Okay, so we're not going to use n equals 0 because that is a trivial answer anyway in the expression. So let's find out what k is. So k equals minus 4 over 16, which equals minus a quarter.